Hey, how's it going, everybody? And welcome back to Michael Workspace. I am Michael, and in today's lesson, we'll be going over the stack data structure. The stack data structure is an abstract data type that serves as a collection of items that follows the LIFO, last in, first out, or FILO, first in, last out principle. This means that insertion and deletion of items happens at the same end, usually visualized as the topmost or rightmost end of the stack. The most recent item that you put on the stack is going to be the very next item that you have access to. And because of this, items are maintained in the order they are added. So when to use a stack? You should use a stack when you want quick access to the most recent item and that you need to keep the items in order. Imagine if you have a stack of plates and the top plate is the one that you can have access to. So you can either remove it or you can add a new plate to the stack. And when you add a new plate to the piles of the stack of plates, it's called push. And when you remove a plate from the top of the stack, it's called pop. You can only interact with the top plate and not any other plates on the bottom before that. So let's go over some real world example or application of having it a stack. You probably have used Microsoft Word or another Microsoft product, and there's always a feature where once you make some sort of addition, you can always revert your changes by hitting the undo button, and it's always at the top left corner of the software. You can also do a redo as well. Now, another example is if you are browsing a website and you flip through different web pages. Well, you have the option to go back to the previous page by hitting the back history button, indicated by like the back pointing arrow. And behind the scene, that is using a stack. So let's go over some stacks operation. There are two primary methods that every stack should have, and the first one is called push method. And when you push, you are adding an item to the stack. The second primary method is the pop method, and this is removing an item from the stack and also returning it to you. Both of these operations has a time complexity of O of 1 constant time, so it's very quick. There are some other useful stack operations, and you might want to implement a peek method, and this can give you the topmost or rightmost item of the stack without removing it. So you have visibility of it without removing it. This differs between the pop method, which will remove and return it to you. You can also implement a isEmpty method and basically just check to see if the stack is empty. And also the getSize method to check the number of items in the stack. Alright, now let's time to get to implementing a stack in code. So right now on screen I have two terminal open side by side. The left terminal will be used for us to code out our stack, and I'll be using the nano editor. You can go ahead and use whatever text editor you are comfortable with. And then on the right hand side terminal is where we're going to be running our code. Alright, so let's begin here. Sorry. Also, a quick one thing to note is that both these are pointing to the same working directory. So now that we're here, we're gonna go ahead and open up a file called, I'm gonna call it stack underscore ds for data structure.py. And let's go ahead and give this a quick doc string. Okay, and I'll be writing this out. I'll be representing the stack with a class. Now you can also use a Python list, which it would be practical to use to kind of showcase what a stack is. However, there's a benefit of creating your own stack because with this its abstraction, you get a better understanding of what a stack, a data structure is, as well as the list. The list object has other methods in there, which is such as insert or remove, which if you were to use that, then you can basically remove an item or add an item to the stack that would basically destroy the order of the stack because it needs to only interact with the top or the most recent item added. However, the insert and remove can also remove an item at different indexes, and that would ultimately ruin the integrity of a stack. Okay, so let's go ahead and begin here. I'm going to call our class name just stack. And the first thing we want to do is create our init method, which is the constructor. And then we're going to actually be utilizing a Python list to utilize some of the helpful built-in function that it comes with. But then we'll give it a different name so that it be only utilized by the stack class. I'm gonna call it items and make it an empty list. So the self refers to this instant of the class object, and items is just the instant properties that is a um, empty list at this point. Let's go ahead and implement another method here, and we're gonna use we're gonna call it push, and we'll be taking in an item. Then we'll use the built-in list append method as the push abstraction. So, and we're going to be obviously appending in the item. And when you append an item, you're adding an item to the stack. Next, we want to implement a pop method. And again, the pop method is a standard built-in method of the list object. Next, we want to implement our useful or helpful method. So the first one would be peek. When we peek, we only want to concern with the topmost or rightmost item in the list, the most recent item that has been added. So we'll just do -1 index, which is going to give you the last item in the stack. And we obviously want to return that. Second, we want to check to see whether the stack is empty. So we'll create another method for that. And there's actually two ways or multiple ways of doing this. So you might be tempted to do something like this. If the length of stack is equal to 0, then return true if it's is empty, otherwise false if it's not. However, this is not very Pythonic. There's a better approach to doing this, and I'll show you here. We can also do this syntax or this statement here, if not self.items. And the reason why this works is because a empty list evaluate to false. So if you do not false, then that evaluates to true. So that's why it works. Next here, let's go ahead and implement the other method. Let me see, which one do we say? Oh, get size. and we return self that the length of the stack. And I think that's all that we need. However, there was one more that I wanted to implement now that I think about it, is that we want a way to kind of print out a stack to see the content of the stack, to see all the items in there. So we want to create a one of our dunder stir magic method, and I'll show you why we want to have this here. But let's go ahead and return a string. This method returns a string representation of our object, and without it, then when we go to print or stack, without this string, without this method implemented, then it's going to print out not the content, but basically the physical address of the stack in memory, and that's not very useful to a programmer. Okay, I think I want to remove this blank line here, and this should be it. Let's go ahead and test this out. I'm gonna go ahead and, since working within this module here, we're gonna go ahead and do something called, you should know what this is. If name underscore if name equals main, then execute the code in this block here. So first we want to do is initialize our stack object. So we're gonna give it a name. I'll just call it stack is equal to stack. That's a constructor. Now we want to verify whether the stack was created, and we just do a print. Now I'm going to write this out to our file by doing Control O in Nano. And then on the right hand terminal here is where we want to run a Python module. Remember, the name of the module is stack underscore ds.py. Okay, so this printed out an empty list, which is what I would expect because we just initialized a stack object, and within the constructor or the init method is just making an empty list. Now I want to show you what happens if we didn't have this string method here. So let's go ahead and comment that out and save the file and rerun our program on the right hand terminal. Oh, I forgot to save. Control O, yes. Okay, as you can see here, with this string method being commented out, we're running the program. It's gonna give us we're printing the stack, but then the stack is gonna return its location in memory and not the content of the stack itself. So not very useful. That's why we have this implemented, this string method here. So I'm gonna go back there and uncomment that out and continue on. Now we want to push a couple items to the stack. Oh, sorry, stack that push, and let's go ahead and push a 1 in there, push a 2 in there, and then let's just go ahead and print the stack now. Can't type at this moment. Control O, save it on the right hand side, run the program. As you can see here, we pushed 2 items in here, 1 and 2, and you can see it in the stack now. Let's go back here and test out some of the other methods. Let's do stack.getSize. And we expect to get 2 here, so let's go save that out real quick again, run it, and we did in fact get 2 as the size of our stack. Let's go back to our test out some more. Let's pop out, let's test the pop function. So that pop, rerun the program. We should only see it's returning, oh sorry, it's returned none, but really it's because it's supposed to return the item itself. So let's go back to our program here, and I forgot to put in the keyword return in front, so that's why it said none. So let's save it again, rerun the program, and Now we actually did return two because two is the last item in the stack. However, and it should also remove the item from the stack. So we can go ahead and prove that real quickly here. So back in our program. So let's print the stack now. Save it, run it, and in fact, that the two has been removed from the stack and only the one remain. This I believe there's maybe only one. Oh, we got a peek method we haven't used yet. So let's go ahead and test it out real quick. I'm gonna go ahead and push another item to the stack because obviously there's only one item in the stack currently, and it's gonna show that. So I want to show you that it only should show the last item in the stack. So let's go ahead and push a 3 in here, and then print the stack, save it. On the right hand side, run the program. Push, it's not defined. Oops, I did something wrong. Stack that push, not the other way around. Silly me. Okay, so now that we have 1 and 3 onto the stack, let's go ahead and do the use the peek method here. Save that. Okay, and as you can see, it returns 3 because 3 is the last item on the stack. And that should be everything here for the class, for the about the stack data structure. I can go ahead and, if you guys want the this class here to use in your own code, I'll push it out to my GitHub so you can have access to it, and I'll have the link for my for this here in the video description. So let me go take care of that real quick here. All right, and I'm just gonna head out to my GitHub now and show you where it is. It's gonna be in the data structure project, and stack.dspy was a file that we just created and also uploaded, and here is the source code for today's lesson. Okay guys, well that's everything for today, and I'll see you in the next one. Have a good one.